The purpose of all academic or intellectual discussion has been to try to find or convey truth or reality, and there have been difficulties in that, but at least within science, there was a guideline was always clear that whatever you say that should not contradict observation, and more than that, that should be whatever you say, whatever opinion you have, that should be judged through or tested by evidence. And there have been works to clarify the meaning of evidence and the meaning of testing. And by mid 20th century, we had a modern standard of evidence in the form of observation by instruments or so, and testing was I think much clarified by, for example, work of Karl Popper, that a theory should be falsifiable or refutable, and then that means checkable, and then successful in actual checking. So there was standard was available as a modern standard. But then mid 20th century onward, there have been a revolt against that, against modernism, and that revolt has been called postmodernism. And postmodernism was, the idea that there is no standard and everyone says whatever it says is due to is context or culture or group affiliation or so. That was always there, but at least within science we had a standard that whatever is, for example, Einstein and quantum mechanics being Bohr and Heisenberg, they disagreed. But no one denied that if it is a clear observation, which is not controversial, no one would dare to oppose it. So that standard was there. But then this standard, very standard itself, observation, that was put to question mark, in the sense that Quine and Duhem and others, and Thomas Kuhn has related thoughts, and they they introduced this mistrust in standards even in science, and that made the movement of postmodernism very serious. And that says that the movement said that observation cannot test a theory because observation itself depends upon theory. The particular detail is that data or evidence or observation does not pinpoint a theory, and you can have more than one theory explaining the same evidence or same observation. And it cannot be checked or tested or corrected by observation, because observation itself assumes the theory. If it itself assumes a theory, then if theory is wrong, then observation will also be accordingly, and then theory cannot be tested. And Duhem and Kuhn made it into a full-fledged thesis, many, I think, books or articles in which they emphasized again and again that observation cannot do the job of checking or refuting or throwing away wrong theories, because if you make any effort to refute or check, they claim, Duhem and Kuhn, same, that we can always find a challenge to your conclusion. Now, the purpose of this lecture is not to go along with this anarchy, and here I have to reply all this. I think these I take as objections, and replies I convey, and these are not my, they are publisher replies. And that's the one is, for example, Encyclopedia Britannica, that if you have a underdetermination, if you have a variety of theories, then you see all them and then take something like common or best results out of them. And to the second objection, that observation pre-assume the theory. I have published books pointing out that this observation pre-assume a theory, but that theory is not what we are testing. So, the details are, I think, as I go in actual lecture. So, and one thing is always there, that if you are think that your observation is your opinion, then you can use instruments to reduce bias. Okay, now underdetermination. What underdetermination means that your evidence does not pinpoint a theory. For example, you have a room, and your evidence says that there are no big difference between two sides, and maybe measurement says that air pressure on both sides are same. Now this is your data, evidence, observation, whatever you call it, and now you have to explain it. And underdetermination says that this observation does not pinpoint explanation. You can have more than explanation. For example, you can say that both sides of the room have same temperature, and that's why they have same pressure measured, and that is science called thermodynamics. Or you can same data, same again, but you can, in trying to explain it, you can think of a more microscopic perspective, or in words of Thomas Kuhn, maybe you can have a more microscopic paradigm. That's the terminology used in postmodernism, paradigm, and difference of opinion is called difference of paradigm, or variety in theory is called also paradigm. So another way of explaining is that you can be more microscopic. You say there are atoms or molecules in that, and each is moving, and because there are equal number of molecules traveling to right and traveling to left, and that has made the pressure equal. So there are two different ways of explaining it, whatever you call them. Now this is a problem, and is it unsolvable? My answer is, and it's not my own answer. It's Encyclopedia Britannica has suggested words to me, that if you have a more than one possible explanation, then try to make best out of the set of explanations you have. One word of Encyclopedia Britannica has been capture the common. If you have more than one explanation, common or whatever best you can do it, considering all. For example, it may be common or consideration of all is that previously, in the previous slide, I had shown you two explanations. One is more microscopic, and the pressure temperature is more macroscopic, daily life type of explanation. So what you can do is, you can try to derive thermodynamics, pressure, temperature, assuming that there are atoms or molecules which are moving in this microscopic detail, and then work out mathematics etc. on this detail, and derive thermodynamics, temperature and pressure. So that means you can call it common or something like that. Could be that you considered both and tried to make the best out of it. Now that is one answer to the distrust on evidence, that evidence does not pinpoint explanation. But as postmodernism is a big movement, and that even inside science it continued, and I mentioned Thomas Kuhn, which is who wrote a book on different paradigms. He introduced the term paradigm, and he called difference of opinion, he named as difference of paradigms. And for example, he would say that the scientists who believe that, that's something like 500 years ago I'm talking about. The scientists who believe that Earth revolves around Sun had a different paradigm than who believe that Sun revolves around Earth. Now, Sun revolves around Earth is a representative is Tycho Brahe, and Earth revolved around sun is represented by Kepler. And Kuhn said that because they had different paradigms, so they had different observations, because they had different theories, so that made their observations differ. And you see that what I've shown you a picture, and he said that those who believe that the sun moves around Earth, they would say that our observation is that sun is moving around sun, and those who believe that sun is at rest and Earth is spinning, rotating, they would say that for example, Kepler would say that our observations say that Earth is rotating. Now here I think reply to that, this is objection on standards, and try to maintain standards. I have something written in the same book from this, I mentioned the title of the book, The Golden Age of Philosophy of Science from 1945 to 2000. That's a period in which the postmodernism developed. And the writer is John Losee, and the writer first mentioned this Kuhn view, and that writer himself herself replied that there are two different they should not be called two different observations. They are two different explanations of observation. Observation is direct observation is common to both. Whatever paradigm you have, you will accept that the distance between this orange, means sun, and grass, this increases the time as sun rises. So this immediate direct observation, that is common between difference of opinion or paradigm or whatever you call it, and that is the standard, and through using that standard you should keep trying to maintain standard of science, and do not give up and say that everyone has its own paradigm. Okay, still it's a full-fledged movement, and that would not give up. And now they made another effort to say that observation misleads, and this time it's a Muller-Lowell illusion, which says that you see this is a thick line, black line, that is a thin, and it was blamed on observation that our observations say this is thick is a lengthier and thin is a shorter, and that's why our observation misleads. Now, before answering, I mentioned another thing, and then I answer together. And another way of saying the same thing is that if you go, which is called mirage, that if you in a hot weather, if you are traveling on a road, that your observation would say that there is water, but actually when you go near this blue color disappears, and you have a road. That means your observation, which showed you this blue, and you interpreted that as a water, that observation misled you. So observation misleads. So the two examples, there are many others, because this is 1,000 years old, or more than 1,000 years old blame on observation. People have always been disliking observation because they don't want to be limited by observation, and they want to keep their freedom. But observation restricts freedom, and people don't like it. So they have come up with many, and I've selected two examples. And now the reply to that could be that there's no alternative to direct observation. You have to see. If you're seeing blue, you have to say, I am seeing blue, and then try to explain it. And here in this thick and thin, if you are getting impression, then you say the impression is wrong, not that the observation is wrong. And if you want to say what is observation, that in that case we can take help of an instrument, and scientific instrument will tell you that these two lengths are same. So there are ways to define observation in which way the observation is not controversial, that's a common. And what is controversial is not observation but a description of observation. You know, Russell has the term is called knowledge by acquaintance and knowledge by description. What acquaintance means, whatever you are seeing to yourself. Don't, before telling to others, you know what you are seeing. You are seeing blue color. So controversies arise when you try to describe your observation to others. So your description can be wrong, but your observation itself, you saw it, there's no alternative to it, that you did see that. Whatever you saw. You have impression, you do say, okay, I have impression. And then you can check impression. But first admit that you have impression, then try to explain why your impression is wrong. But here I think main emphasis, my main reply is to instrument. Through instrument you can check your impression as well. So impression was wrong. Your description may be wrong when you to tell others. Or your understanding may be wrong, but not observation itself. This, whatever, there is something, even by your eyes or by your instrument, there is something is there which you can use as a standard to control the variety, as a check on variety. Okay, and then I say one objection was this time raised by Kuhn and Quine. And this is explained by, illustrated by, an example is given to what is called Duhem-Quine thesis. An example is given by in a book called titled Theory and Reality by Godfrey Smith. I have to tell you page numbers. And that says that, for example, your P is a shorthand for preposition, and that preposition is a standard philosophy term for normally what is called a statement. It's a statement that you want to test, and your statement is that higher pressures leads to stable weather. You do certain analysis through observation and evidence and saying, and you have a report, and the bottom line of the report is that observations seem to find that at high pressure you do not have stable weather but rather unstable weather. Now that is, if observation is checking, then that means this your proposition was not successful in checking, and that was rejected. But Kuhn and Duhem, they say that this checking can always be challenged. In that it's not necessary that your assumption, your proposition was wrong. Maybe your barometer was wrong, or maybe you did not have a good method of reading off or knowing weather conditions, and so there can be one way or other of creating doubt on your any scientific conclusion you have it. And and claim that we can always doubt, we can always challenge a refutation on any scientific standard by observation. That is called Duhem-Quine thesis. Okay, now reply to that, in reply to Duhem-Quine, before replying I should say that a slightly different, apparently different word of Duhem-Quine theorem as thesis has been that your theory, your observation, in the previous I take you to back here. Your observation is through barometer and weather condition or so. And you are, through this observation, you want to test your given assumption, proposition, but your observation used barometer, and your observation assumed that barometer is correct. So that means your observation depended on a theory. So observation cannot check a theory. In this form, the Duhem-Quine theorem is called theory dependence of observation. Another way of saying is observation is theory-laden. Okay, now answer or replies to that is, the first is reply is by Encyclopedia Britannica, is that says that the historical examples on which Queen and Duhem depend upon that, they are not many, they are exceptional, they are few, and they have exaggerated, and they have made a case, as it were. This is always the case in science, where it's only a rarely case in science. That's for that you have to know history, and I don't have time to convey you history. But here, what I can clearly myself convey is that what they said, that theory an observation depend upon theory. Your observation of weather depend upon theory of barometer. Your observation depended upon a theory, so observation cannot check a theory. If theory is wrong, that would make observation also wrong, and all in all, there will be no way of checking it. That is the objection, that is the Duhem-Quine. And the reply to that is that actually they don't understand that they are using the word theory twice. One is the theory which is assumed by observation, and one is a theory which is tested. And they assume they are same, but that is wrong. Most commonly, the theories are different. When you make an observation and you make a background assumption that there is a theory, I mean, basically the theory, background assumption theory means that your apparatus is right, and your parameter, or maybe now I show you an example of what is called emitter or so, or your circuit is right or so. That's a theory you assume. But you make a circuit or so, and I think you check it. To check a theory, when you check a theory, that theory is not a theory of circuits. I think I show you a circuit, what I'm saying. Circuits are mentioned here. Chalmers. I come back to Losee later, but further, because I started speaking about circuits, so I better show you the sentence where I was speaking to that. That your experiments are established, your observation is there, and all your testing is ready. In that you assumed a theory, and you assumed theory that your circuit is right, your electronics is right. But that's a theory you assumed, and what you assumed, what you taken for granted, that you cannot check. Agreed. But what you are checking is not that theory of circuits. You are checking something else. If you see Chalmers page 36, they have an example of some generally scientific theories which made convert from the old physics to the new 20th century physics of relativity and quantum mechanics. And the relativity and quantum mechanics, they are not theories of circuits. They are full-fledged different theories, and these theories were tested. And if something was wrong, was old theory, and your old theory said that emitter reading should not increase. But when you have made a circuit, your background theory says the emitter reading should not increase, for example. With background and the theory you are testing, that also combined, they said that the emitter reading should not change. But if emitter reading changes, can your theory which you are testing, will it be able to stop observation? Not. If observation is there, if a needle has to move, it has to move. It will not ask what is the theory you are testing. Whatever your theory you are testing, your needle will move, and then accordingly you have to say if your theory not your background theory, the theory you are testing. If your theory you are testing can accommodate that movement, good. It is not. There is this. Maybe you have to discard that theory, throw away that theory, if observation is confirmed. So that is what Chalmers said. And meanwhile, I had Losee, who talked about Tycho Brahe and sun and earth movement that I mentioned in slide 4. The author Losee says the same thing is that that statement about what is observed or accepted and not independently of theoretical consideration. That means we do assume some theories, but we do not assume, but whatever our observation are dependent on theory, but that theory is not what we are testing. So that means what we are testing, that can be checked. A conclusion you can see yourself, and I think I leave you here. Thank you very much for watching.